Good afternoon, everyone. I welcome all of you to the most comprehensive exam prep app, that is BYJU'S Prep app on YouTube. So, as you know, we have started this IIT Kharagpur series, and today is the session we are going to conduct for the fluid mechanics. Those who are interested, please join fast and like the session so that we can start our. I hope I am audible and visible to all of you. Please hit the like button and let us start our session now. Please share it. Do not forget to share with your friends, and please do not forget to hit the like button. Hello Shubham. So last class I have conducted it for IIT Kharagpur strength of material, and I told you what are the chapters and what generally they are asking. See, this is not someone can predict exactly what is their intention and what kind of questions they will be asking, whether it is related to any particular subject or whether it is related to any particular chapter, isn't it? Hello Yavar. But the thing is that once we have a previous year question asked by IIT Kharagpur, one can go with some of the statistics, and one can, based on the previous data, one can say something. In that perspective, I have said that they were more or less more interested in deflection chapter. More questions were asked from the deflection chapter compared to any other chapter. Now, if you'll see the fluid mechanics part, OCF has been, we have segregated that OCF and fluid mechanics. And in fluid mechanics, if you see, not much questions. Comparatively, they have not asked much questions. Although, although you can see that already hydraulic machine has been removed from your syllabus, right? So fluid mechanics, now it is time to think about, even though if you are going to ask the question, if hydraulic machine has been removed, what will be the portion where you need to emphasize? So let us first of all start conducting the questions, then I will tell you in between which of the portions you need to take care, because every educator or every person who is teaching in this particular field will be having some kind of statistics, some kind of expectations, or you know in the perspective that they can provide you some data or some chapter which you must go through it with for the aspect of GATE 2022. So now let us start our session. This is my introduction, and you can join me on Telegram channel. So this PDF will be available to you. You can always join me on your Telegram channel. The PDF for this session will be available to my Telegram channel, which is Civil by Ansari sir. One second. Oh, please, one second. Please give me 1 second. I don't know. There is a very small problem. Yes, Yavar. How to start gate preparation? That is very easy. See, first of all, you decide in which year you are. You are in third semester. So third semester student has to go through each and every subject very carefully. Each and every subject very carefully. Please give me few minutes. There is a small issue I'm going through. Oof. Just give me few minutes. I'm just doing it. There is a small issue I just encountered here. Meanwhile, if you have any doubt, please ask me. I actually got a trouble, some technical trouble. I'm contacting my technical team. They will just resolve it. Yes, yes. You are asking Yavar that some of the students has a question that how to start for the third semester. See, if you have enough time, those who have enough time, one thing I would like to convey, the message is that simply, if you have enough time, you just prepare according to the syllabus, complete the syllabus, and while completing the syllabus, try to gain the conceptual understanding of. See, I'm not going to say that you must be 100%, you should grab 100% conceptual concept for each and every topic, each and every syllabus. If you are in the preparation strategy, one should understand that the preparation is something where you are not going for the research, right? So even though if you are more or less capable of understanding 60 to 70% of the syllabus will be more than enough, isn't it? So 60 to 70% of the syllabus one should understand at least. Rest of the maybe 40 to 35% you can manage it. And at the same time, wherever you have a wherever you are completing your conceptual clarity with subjects and all, you go for your previous year question also. Without previous year question, you cannot expect, because you will not be having the understanding what kind of questions they're asking. So prepare accordingly and try to find it out what is your previous year questions. While solving the previous year question, you will understand what type of questions they're asking from these topics. So side by side, if you are completing the syllabus and solving the previous year question, will always help you. It is going to always, and obviously it is going to help you a lot. Did you get that? I have sent a doubt problem in Telegram channel. Yes, Raju. I'll see. I'll see today. I'll see today your Telegram doubt. It is a structural analysis problem. Acha, for let it be. Now they are solving it. If they will solve, it's a good one. If they will not solve the the technical issues, if will not be resolved, I'll take the session at some another time. That is not the problem. But one should understand one thing. Session is started. Session is already going on. I'm there with you. One more thing you understand from the fluid mechanics chapter, though I told you that I will be telling you in between that which of the chapter you must go. See, already if they have removed the hydraulic machines and all, of course they will be going to ask, either they will reduce the number of questions, the one which they are asking from the fluid mechanics, or even if they are going to ask same number of questions from the fluid mechanics, somewhere I will say that you should go through this, your normal chapters only, along with that boundary layer, and some of the boundary layer questions maybe they can ask. In the previous past few years, if I'll see, they have not asked much questions from the boundary layer. The IIT Kharagpur, they have generally asked only one or two questions from the boundary layer. So I will suggest you, or maybe I will, it's not, see, no one can predict it completely, but I can say that you can go for the boundary layer and drag chapter. These chapters you please complete it, and my expectation is that some of the questions obviously they are going to ask. Then if you have any other questions, please ask me in between. I will answer your questions, no problem at all. Vortex problem also, uh, yes, you can expect some vortex problem also, that, but see, that is once again, if you will ask one by one, that is quite difficult for anyone to predict that they are the questions which they will be asking, of course, Raju. But the thing is that this is my my expectations and my understanding that they will be asking some more questions in the future from the boundary layer and drag, because they have not asked much questions from the boundary layer and drag. uh, I'm aerospace engineer preparing for aerospace gate structure syllabus. Fluid mechanics are similar, so can you help me how to catch up with this? Your SOM classes were very helpful. Oh, thank you, Abhishek. uh, where are you from completing this aerospace engineering? From which college you are completing that aerospace engineering? Can you please tell me? Yes, aerospace has a similar kind of strength of material, and fluid mechanics they have a same. Even mechanical also, mechanical, civil, also has the same almost strength of material and fluid mechanics. And fortunately, I don't know, Abhishek, whether you know it or not. My master's is from aerospace engineering only. Hello, Abhishek. Here's the first question, that dimension of kinematic viscosity. What is the dimension of kinematic viscosity? What is the dimension of kinematic viscosity? So if you know the unit of kinematic viscosity, that is more than enough. What is the unit of kinematic viscosity? That is meter square per second. Of course, meter square per second is L2, and T is the representative for time, so T minus 1, that's all. Or L2 by T already given, so that's all, finish. Cavitation is caused by, all of you know that. What is the cause of cavitation? If the pressure goes below vapor pressure or till vapor pressure, so vapor will formed and it will get collapsed. It will doing some erosion also. It will erode the surface, which you will generally find out where the very high velocity is present. At very high velocity only there is a chance that the pressure will drop. Sudden drop of the pressure will happen, isn't it? So at very low pressure only it arises. Low pressure problem, that you all know about that. Now here is the problem. 3 rigid buckets shown in the figure. Actually this is very easy problem, but they have elaborated the problem in such a way that it looks like it is a difficult. Sometimes maybe you think in that way, but if you understand the problem, you will find that it is comparatively very easy. How? I'll tell you. See, you know that he's asking about what is the pressure if the base has the same area. If the base has same area, that is A here and A here and A here. If the base has the same area, what will be the first of all pressure at some depth? You know that it doesn't matter what is the shape of the container and all. The pressure depends on gamma WH, isn't it? Pressure at any depth depends only on gamma WH, that is depth. So pressure will be pressure at any depth. At any depth is nothing but gamma WH. Now this gamma WH, if you will multiply this gamma WH with the surface area, you will get the pressure. So pressure, if you want to find it out, everywhere at the bottom, this is the bottom of the container, and the bottom of the container everywhere is some only area A. You know that simply whenever you want to find out what is the force. So pressure already you know that at a depth H it will be gamma WH. If you want to know what is the force at the bottom of this particular container or bucket, the force will be same, because the area is same. Pressure multiplied by area, pressure multiplied by area, pressure multiplied by area. It will be remaining force, that's all. So force here either for the container 1, 2 or 3, as long as they have a same base and as long as they have a same height, you are going to get the same force at the base. So either option C or D will be correct. Now another one, see what is the very, they are asking which will be having more weight. It is very obvious, no? Gamma W is the unit weight of the water, isn't it? So as long as you have a more and more volume of the water, that will be having more weight, that's all. So container 2 has a more volume. If you'll see, it is very easy to understand. See, it is very easy to understand. This is your base area. From the base area, the volume of the container, if you see, the second volume of the second bucket has a large volume, then your first one, then third one. So as long as you have a large volume, because gamma W into volume will give you the what? Unit weight is what? Volume, weight by per unit volume. So weight by volume multiplied by volume, you'll get the weight. So weight wise, if you are going to understand the bucket which is going to contain more and more water will be having more weight, that's all. Are you able to understand that? So W2 will be more than W1, W2 will be more than W1, and where is that? W2 will be more than W1, and I think there is some issue with this option. I think W2 will be obviously more than W1, but W1 also will be more than W3 only. I think there is either some problem. It must be greater than only. It must be greater than only, isn't it? It is depending on the amount of water. It is very normal. Any nominal thing you can understand. If you are containing the more and more water, of course the weight also will be more. So, and remember that force at all the base, force depends on what? Force depends, see, it is about pressure. If I'll ask you what is the pressure at the base, whatever the, see, even though container is like this, or maybe it is like that, whatever it is, whatever it is, if the water is at some level, just a moment, suppose this is your water, right? So pressure actually depends only on depth, not on the surface area, not on the container. Once you will know what is the pressure at the base, multiply, if all the container has same base area, if the all container has same base area, if the area at the base are same for all of them, force also will be same. Of course, F1 will be F2 equal to F3. Here is the some problem. D must be the answer actually. Now what about this problem? Fourth one. What about this problem? An incompressible homogeneous fluid is flowing steadily in a variable diameter pipe having the large and small diameter as 15 cm and 5 cm respectively. If the velocity at a section at the 15 cm diameter portion of pipe is 2.5 meter per second, the velocity of the fluid at a section falling in 5 cm portion of the pipe. This is also quite simple, isn't it? This is also quite simple. How? See, this is the incompressible homogeneous fluid and it is flowing steadily in a variable diameter pipe. So simply if you will apply your normal continuity equation, you will be able to do that. That is discharge. V1A1 equals to V2A2. V1A1 equals to V2A2. If you do V1A1 equals to V2A2, if you do at one place already they have given the where the diameter is 15 centimeter, the pipe has a the fluid has a velocity or water has a velocity of 2.5 meter per second. 2.5 meter per second. And they're asking at a diameter of 5 centimeter what will be your velocity of the fluid. Simply, so V1 A1, what is your V1? So A1 is 15 centimeter. So let us take that diameter in so V1 is 2.5 and A1 is pi d square by 4. Pi d is 15, pi d square by 4 must be equals to V2 they are asking, isn't it? A2 they have already given, which is at 5 centimeter of diameter, pi d square by 4. Now from here if you will calculate, you will get 22.5 meter per second. That's all. From here if you will calculate, you will get 22.5 meter per second. Now a plane flow has a velocity component x by t1, x by t1, and v equals to minus y by t2, and w is equals to 0 along x, y, z direction respectively, where t1 is not equal to 0 and t2 is not equal to 0 are constant having the dimension of the time. The given flow is incompressible if नहीं रो बॉय, मैं वहां नहीं था. The given, so which of the, see, this question is also quite simple, more or less these, continuity equation is very useful. If you see that they will ask generally wherever you go, the related to continuity equation, you will get a lot of questions, right? And for a plane flow means what? It is a 2D flow, right? And for the 2D flow, you can always say that what is your continuity equation for the plane flow? Del u by del v equals to del u by del x plus del v by del y equals to 0. That's all. W component is 0, no? Otherwise, the continuity equation for del u by del x plus del v by del y plus del w by del z will be equal to 0. W already they have given that no component in the w direction. Now, a flow exists only if it satisfies the continuity equation. If it satisfies the continuity equation. And as long as it is obviously incompressible, rho component will become constant and rho component also has been taken out, right? That is, already that what is the complete continuity equation, del u by del, then u rho, that rho u by del x, like that. Obviously for the incompressible flow, the rho component is constant, the density component will become constant, and you can take it out as a constant. Then only you are getting this equation for the 2D flow, 2D incompressible flow. Once the continuity equation will get satisfied, the flow will exist. Now u component and v component has been given. If you just put it here, you will find that 1 by t1 and y by t2 will become, it is actually minus, so minus of 1 by t2 equals to 0, and from here you'll find that t1 is equal to t2. That's all. T1 equals to T2, isn't it? All of you, please do not forget to like. I know I have taken a lot of time to start this session because I got some of the technical problem here, but please do not forget to like the button. Now another question is that a horizontal nozzle of 30 mm diameter discharge a steady jet of water into atmosphere at a rate of 15 liter per second. The diameter of inlet to the nozzle is 100 mm. The jet impinges normal to a flat stationary plate held close to the nozzle end. Neglecting air friction and considering the density of water as 1000 kg per meter cube, the force exerted by the jet on the plate, as long as the plate is flat, it is quite a simple question, isn't it? As long as the plate is flat, even though if he is not saying that the plate is flat, otherwise the curved plate also can be asked, isn't it? Or the moving plate can be asked. He is asking about the stationary plate. Stationary means no movement on the plate, no velocity for the plate, no initial velocity for the plate. So what must be the conclusion here? See, jet impinges on the stationary flat, the force exerted by the jet will be rho AV square, that you know that. Force exerted on a stationary plate by the jet will be rho AV square. What is the problem now? The problem is that here the velocity of jet is not known to us when it is exiting, isn't it? Or the velocity by which it is going to hit the plate. Because he's saying that the horizontal nozzle of 30 mm diameter discharge a steady jet of water into the atmosphere at a rate of 15 liter per second. Actually, the discharge has been given. Once you know the discharge by using the normal continuity equation A1 V1 equals to A2 V2, you can always get the velocity of the jet, isn't it? So discharge is given. So what will be the velocity of the jet? Velocity will be the discharge is 15 liter per second. 1 liter is equals to 10 power minus 3 meter per second. 10 to the power minus 3, na? So it will become 15 liter. If you change it to the meter cube, so 1 liter equals to 10 to the power minus 3 meter cube. So it will become 15 into 10 to the power minus 3 meter cube per second. That is discharge. The discharge divided by area will give you the velocity. And the area when it is exiting the nozzle, that horizontal nozzle of 30 mm diameter discharging. So 30 mm means you just change it to the meter also. Meter it will become 0.03. So pi by 4, 0.03 square. That's all. Pi d square by 4. This is the area of the nozzle through which your discharge is coming out. So discharge by area will provide you the velocity. Calculate the velocity, how much you are going to get it. That is around 21.22 meter per second. Now use the velocity here to get the force. That's all. Use the velocity here to get the force. Now force will become how much? Force will become rho. Rho already they have given to use as 1000. Use 1000. Multiply by A. The area of the jet which is hitting your stationary plate. Area of jet which is hitting your stationary plate. What is the area of the jet? Just now we have seen that 30 mm nozzle is, the fluid is coming out or water is coming out from the 30 mm nozzle. So area will be pi d square by 4 and d we are going to take it as 30 mm, which is in meter. I will write it down as a 0.03. Pi d square by 4 into rho A and then v square. V already we have calculated, that is 21.22 square. That's all. 21.22 square. If you calculate the force, what is the total amount of the force you are going to get here? .318.29 Newton. That's all. Next one. The relation that must hold for the flow to be irrotational. Those who are studying that, a lot of times I told you that you please do remember this I, J, K and del U by del X and and like that, del u by del v by del y, or no, you remove uv from here, only del operator you provide it here, del by del w, del z, then here u, v and w, half. Now the rotational part, you know that the flow must be rotational when the flow will become irrotational. Once you are the velocity component in the z direction, which is nothing but the angular velocity in the about z direction is 0, then it is irrotational, that's all. So half of, if you see here, del by del x, I have written here del by del x into v, so del v by del x minus del by del y into u minus, already you know that how to multiply this, right, to get the z component. It is del u by del y. Once if this is equals to 0, your flow is irrotational. This is the condition for the flow to be irrotational. And hence, of course, this del v by del x is nothing but equals to del u by del y. This is the condition to get, or I don't know how they have written del v by del x. No. How they have written? Oh, this is matching here. Del u by del y minus del v by del x. Either you send it to that side also, no problem. Which of the condition is matching, that's all. Del v by del x. Whatever the way you want to write it down, that's all. Now, if you see this question, this one also, the particle moves along a curve whose parametric equations are given. And he is asking simply the magnitude of the acceleration of the particle, right? Magnitude of the acceleration of the particle. How you will calculate the acceleration of the particle? So acceleration vector you can calculate as an acceleration vector will be axi plus ayj plus azk. How you will calculate the ax, ay and az? The displacement vector they have given. Now you can always calculate, if you differentiate, if you do that dx by dt, what you'll get? You'll get the velocity simply. This is quite simple, isn't it? 3t square plus 2, that's all. If you differentiate once again, you'll get the x component of the acceleration, that is ax. Differentiate it, how much you'll get? 60, that's all. 60. Then what is your y component? What is your y component? So write it down also, no problem. That is 60i plus. What is your y component? Y component is given as y equals to 3e to the power minus 2t. Differentiate it, you will get the velocity, that is dy by dt. You do that. Minus 6 e to the power minus 2t, that's all. Differentiate once again. How much you'll get? By differentiating once again, you'll get ay component, that acceleration in y direction. Y component of the acceleration you will get, which is ay equals to minus plus, so plus 18 6 e to, oh no, this is 2, right, sorry, 12 e raised to minus 2t. Similarly, you do it for the z component also. Differentiate it once. It will become what? See, sine 5t, no? So you will get dz by dt equals to sine, differentiation of sine will become cos, so, and that 5 also will come out, 5 10, so 10 cos 5t. Then differentiating once again, you will get the az component, but cos is minus sine, so you will get 10 50 minus 50 and at the same time sine 5t. Write it down. That is the acceleration component, acceleration vector for all this, right? 60i, then 12 6 this is simply 12 e to power 12 e raised to minus t, that is plus only 12 e minus 2t, j and aj already you have minus of, or instead I can write down directly minus of 50 sine 5t. Now he's asking what is the acceleration, magnitude of the acceleration at t equals to 0. Put at t equal to 0, that's all. At t equal to 0, this component will go. The x component will go away, isn't it? Because here t is present. Sine 0 also will become 0. This component also will go away. This k, sorry. Only you will be getting 12 e raised to the power 0, it will become 1. So 12, that's all. That's all. Isn't it? Only you will get 12. So the magnitude of the acceleration will become what? That's all, 12. 12. Now another question. A horizontal jet of water with its cross-sectional area hits the fixed vertical plate with the velocity of 5 meters per second. After impact, the jet split symmetrically in the plane parallel to the plane of the plate. The force of the impact of the jet on the plate. Force of the impact, force of the jet, force of the impact of jet. Force of the impact of jet. So this is maybe your plate and a jet is striking here and it is going away parallel to the plate. Now you already know that. Just now I have written for, no, a few slides back I told you what is the force exerted by the jet on the stationary plate. The plate is stationary as long as. So if this on a stationary plate, it is nothing but rho a v square, that's all. Nothing but rho a v square. Rho a v square. And this rho a v square will become, rho I can take it as 1000. Earlier it has been given on some of the problem. And area of the jet they have given as 0.0028 meter square. And the velocity of the jet also they have given. So this is a quite of direct question, 5. That's all, 5 square. If you calculate, you will get the force exerted by the jet, isn't it? Which will be around 70 Newton. The velocity field for a flow is given and density varies as rho equals to rho naught exponential of minus 2t. In order that the mass is conserved, the value of lambda should be, what will be the value of lambda? What will be the value of lambda? In fact, sometimes these questions already we used to solve in classes also. The value of the lambda also can be solved. So first of all, what is the equation we have if the mass is conserved? That already I just wrote it down. Del u by del t plus del rho u by del x plus del rho v by del y plus del rho just now I have written, isn't it? Del rho by del z must be equal to 0. Must be equal to 0. Now find out that del rho by del t. Rho has been given. Rho is varying. Rho is varying with this component. Rho equals to rho naught e raised to minus 2t. What will be d rho by dt? Del rho by del t. It will be nothing but rho naught and minus of 2t. Minus of 2 rho naught e raised to power minus 2t. That's all. Isn't it? That is nothing but once again, I can write it down, that is nothing but minus of 2 rho. Minus of 2 rho itself. So I'll write it down here. This is minus of 2 rho. Then plus. If you will differentiate here, rho u by del x. Now all the component you are going to differentiate with respect to x. Here the rho component will be your constant because you do not, that rho is not varying with respect to x, y or z. It is only varying with respect to time. So you can take the rho component common as well. Right, now del u by del x, just if you find out del u by del x, you will get 5. Then what? Rho del v by del y, you will get 5. This is 5, correct? No? Del v by del y also 5, okay. Then del w by del z, you will get lambda, that's all. So rho into lambda must be equal to 0. Just simplify this. How much you will get? This is 10 and 10 minus 2 rho, that will become 8. So 8 lambda will become minus of 8. That's all. There is another question. This is quite theoretical one. If you remember that, then only you will be able to answer. It was asking about to match it, right? All most of the time we know that anemometer we are using it for what? Pitot tube we are using for what? Hygrometer we are using for what? Isn't it? Several times you have already gone through that pitot meter, anemometer you are using to find out the wind pressure. Then wind pressure. So P will be 4. This means either C or D. Either C or D. Then after PQ, that hygrometer. Why you are using for hygrometer? Hygrometer you are using for water vapor in the air. What is the vapor in the air? It means Q will be hygrometer used for third one. So Q third. Now it is option D. Option D. Only after finding out only the two component. Although pitot tube also will see which one. Fluid velocity at a specific point in the flow of area. That's correct only. You want to calculate, you want to know what is the fluid velocity at some specific point, you are using that pitot tube. That's all. So last one is your capillary potential used by tensiometer. So option D is the correct one. But generally this type of question you will not be expecting to get repeated. Here in the numerical portion, you can expect the questions can be repeated with the concept. Some data will be changed, some different type of questions you can expect. What will be the answer for this one? This is related to venturimeter, isn't it? Venturimeter problem. A venturimeter having a diameter of 7.5 centimeter at the throat and 15 centimeter at the enlarged end. Okay, let us first of all draw the venturimeter. So at the enlarged end, the diameter he is saying is 15 centimeter, right? Installed in the horizontal pipeline of 15 centimeter, of course. At the enlarged end, whatever the diameter will be, it will be the diameter of your pipe only, isn't it? Through which you are going to connect your venturimeter. Then at the throat, the diameter is given as 7.5 centimeter only. 7.5 centimeter. So let us say these 2 points are there now. Let us say these 2 points as some 1 or 2 or x or y. Here it is 7.5 centimeter. The pipe carries an incompressible fluid at a steady rate of 30 liter per second. 30 liter per second. And the difference of pressure head measured in terms of moving fluid in between the enlarged and the throat of the venturimeter is observed as 2.45. This is the difference of head he has given. Difference of pressure head he has given. Difference of pressure head measured in terms of moving fluid between the enlarged and throat of the venturimeter is observed. So difference of pressure head means if they have given the difference of pressure head, 2.45 meter. Then what he is asking, taking the acceleration due to gravity 9.81. Okay. The coefficient of discharge of venturimeter, correct up to 2 decimal. So what will be the coefficient of discharge? Coefficient of discharge generally see, I'll write it down. Coefficient of discharge. Coefficient of discharge we are calculating by, theoretical and actual one. Ratio of the theoretical and actual one will give the coefficient, or coefficient of discharge can be calculated like that, isn't it? So I'll write down that equation, that which we generally use to remember that discharge CD, then A1, that A1 A2 or directly let me write down coefficient of discharge. Coefficient of discharge, that actual divided by theoretical. So coefficient of discharge is actual Q divided by the theoretical one is A1 A2 divided by under root A1 square minus A2 square and under root 2GH. That is your coefficient of discharge. That is your coefficient of discharge. Now they have already given that fluid is having a discharge rate, steady rate of 30 liter per second. That discharge is already given. Now if 30 liter per second is given, Q will be 30 into 10 to the power minus 3 meter cube per second divided by A1 A2 already can be calculated because the dia is given, and dia already given A1 A2. So this is quite calculative only. A1 you calculate pi d cube, pi d square by 4, so pi, and you can change it to meter, so pi d square by 4 for A1. Then for A2 it will be pi d square by 4, that is pi and 7.5, okay, that will be 0.075 square by 4 A1 A2 divided by A1 square minus A2 square. Just to put the values here, or in fact you can calculate the A1 A2 also separately. Square minus under root 2gh, under root 2gh. 2g is 9.81. okay, where is h? H they have not given, and to get the h value only, they have given or not the h value to, oh they have given, no, that h 2.45 meter. The difference of the pressure head already observed is 2.45 meter. That head difference also given 2.45. That's all. Head difference also they have given as 2.45. If you calculate from here the CD value, you will be getting around 0.95. But this is quite calculative. You will indulge in the, maybe you have to take care for the calculation. No, don't do mistake in calculation. Now once again a question from venturimeter. Previously if you see, they have lot of questions they've asked from the venturimeter itself, and it is also looking like they have asked it from a venturimeter having throat of it, and I used estimated flow rate of horizontal pipe from C, and the coefficient of discharge equal to unity. CD value they have already given. CD value they have given. What they are asking then? Assuming that the energy losses are negligible, the flow rate through the pipe. Okay, now this time they are asking about the discharge. This time they are asking about the discharge. That discharge I have told you, CD is nothing but what? The ratio of the discharge. So now discharge can be calculated as CD into the one which I have written just now. A1 A2 divided by under root of A1 square plus minus A2 square under root of 2gh. Once again it is a kind of calculative one. That's all. So CD value already 1 they have given, then A1 A2 already you know that. Or you can calculate separately. A pi d square by 4. Venturimeter having a throat diameter 0.1. So, and then pipe having diameter 0.2. That's all. So 0.2 square, then pi by 4, 0.1 square whole divided by under root of pi by 4, 0.2 square minus pi by 4, 0.1 square, then under root of 2gh, 2 into 9.81 into h. H is the difference of head, which is already given. The difference of head is 2 meter. Difference of 2 meter of water head. That's all. Difference of head already they have given as a 2 meter. Now if you calculate this, the discharge, only if you do the calculation, the discharge will get around 0.05079 something or 78, the one which I have calculated. So 0.050 is like quite matching with the answer. But these two are, you will say, is this was also 2014 and this was also from 2014 only. They asked this question for set 1 and set 2, this venturimeter related to coefficient of discharge. They two are quite simple, same. This question actually looks big, but this is quite simple one. This question actually, it looks big, but this is quite simple if you'll see carefully. They've given the velocity profile, right? What they've given, the velocity profile they have given. Then they're asking about the Umax. What will be the Umax and U average, isn't it? How you will get the Umax and U average? With reference to a standard Cartesian coordinate plane, the parabolic velocity distribution profile of a fully developed laminar flow in between the plates, in between the two plates, right? Parallel plates. This parallel plate problem. Now, in between the parallel plate, you have a flow, and the velocity profile has been given. This y distance, you already know that in this equation y equal to 0 axis lies equidistance between the plate at a distance h by 2 from the two plate. Even though if he is not going to tell, no, I will tell you that y has been given from that only. It is looking like that. Okay, let us avoid that one. That will once again lead to another kind of discussion. But yes, the two plates are there. Two plates are there, and there is a flow between the two plates. And he's saying that the y he has considered from the central one, and hence y is 0 at on this axis. That's what he's saying. Then the y equal to 0 axis lies equidistance between. Is it visible to all of you, the question? P is the pressure variable and mu is the dynamic viscosity term. The maximum and average velocities are respectively. What will be the maximum and average velocity? Umax and U average. What will be the maximum and average velocity? So maximum is quite easy to get it from here. Although this question very look big, but believe me, this is quite simpler one. You see one thing. For the parallel plate, those who have completed the concepts, the plate as long as not moving, that is what he is already saying it. The plates are, see, can you read it out? Stationary and identical plates are separated by a distance. When the fully developed flow will be there, it is very obvious that the maximum velocity you are going to get at the center only. At the center only. What does it mean? Means at y equal to 0 only you will get the maximum velocity. Are you getting the point? So at y equal to 0 you will get the maximum velocity. So Umax will be observed at y equal to 0. Put the y equals to 0 value here. Put the y equals to 0 here to get the Umax. That's all. So Umax will become how much? If it is 0, it is minus of h square. So that's all. Minus of h square by 8 mu. Minus is there. dp by dx. That's all. Now you see. Oh, all options has same. See, that is the problem, no? All the options are same. It is given h square, so it's satisfying. U maximum is satisfying to all of them. Now calculate what will be the U average. That is quite calculative one, little bit. Only the integration part you have to do. That's all. How you will calculate the average one? The average one, you know that there is a velocity profile. There is a velocity profile. So small area you consider, multiply with small area to get the discharge, integrate it all over the area, and find the discharge divided by the total area will give you the average, isn't it? You are now seeking towards the average velocity. Sorry, average velocity only. So to get the average velocity, how you get that? Discharge you calculate divided by total cross-sectional area of the through which it is passing by. Right? Now the discharge, how you will calculate? The discharge will be nothing but you have a velocity profile. Consider small elemental area dA. You have a velocity profile from top to bottom, right? Now small elemental area dA you consider and just integrate it all over the area, isn't it? And throughout the sea, actually, if you consider the width of the plate, you don't have a variation across the width of the plate that we are not going to consider across the width of the plate. So only the depth is going to get the problem for you. So only you integrate it about the depth, that too you can integrate. So only it is about calculation, only about calculation. You can integrate from 0 to y equals to h by 2. You can integrate from 0 to h by 2, multiply by 2, take the unit width of the plate, take the unit width of the plate to get the velocity. Now u average is nothing but q by a, right? U dA, you write down the u value already you see. This will become, this is nothing but d till this it is, I can write down this u also like u max into 1 minus 4 y by h square, isn't it? Y by h square. Write down this much because this will become easy for you to write down every time. This whole terminology is a u max, no? You write it down u max, write it down u max. So write down that one. It will be u max, then 1 minus 4 y by 4 square, y by 4 square into dA. That is your q. Then q by a you have to do that calculation. Q by a you have to do. Integrate it over the area. That dA is how much? dA, as I told you, you are going to consider it for the unit width of the plate. If you are going to consider it for the unit width of the plate, consider only the strip of unit width, stripped with the dy, right? Dy is the height. Now the area of the small strip will be dy into 1, dy into 1. So that dA you can write down. Let me write down one more step and then I'll directly write it down, because now it take a lot of space here to calculate. The q only, or maybe let me write down the final u average. That q portion, or what I'm saying, that you integrate it from h by this is u average will be, write down the discharge which you have written 0 to h by 2 u max 1 minus 4 y by h square, then the small area dA. That small area dA will be dy into 1. I have taken as a width. I am not, there is no variation in the width direction, right? Divided by dA. So now dA will be what? So divided by total area. What is the A? I know what is the height. Total height is h, and I have considered as a 1. Width of the plate I have considered as 1. So the total area will be h into 1. That's all. Now integrate this one with respect to y, and simply you will get the u average value. Which is nothing but 2 by 3rd of u max, which you are going to get as a 2 by 3rd of u max. This is now simply in an integration. If you will integrate from here with respect to dy from 0 to h by 2, you are going to get 2 by 3rd of u max. U average will be getting 2 by 3rd of u max. This is simply calculative. It is looking like a big question, but it is nothing but more or less it is mathematics only. Not much fluid mechanics questions you have available. Thank you for all of you. Please take care, and rest of the questions I'll be taking here in another session. I'm really sorry that due to some technical error I was not able to take the class on time. Thank you all of you.